Imagine approaching Jupiter for the first time. Not in a textbook, not in a documentary, actually approaching it. From a distance, it looks almost serene. Swirling bands of cream and orange, that famous red spot, beautiful in a way, the jewel of our solar system. But as you get closer, something changes. The radiation alarms start screaming, your instruments begin malfunctioning, the scale becomes impossible to process. And then you realize something terrifying. You're not approaching a planet, you're approaching a monster, a cosmic nightmare that's been raging for 4.5 billion years, a failed star that came within a mathematical whisper of igniting and turning our solar system into something completely unrecognizable. Jupiter isn't the gentle giant we imagined. It's the most violent, destructive, incomprehensibly massive object in our neighborhood, and it's been quietly reshaping reality since before Earth had oceans. Let's start with something we think we understand: size. Jupiter is big. Everyone knows that. But saying Jupiter is big is like saying the ocean is wet. It's true, but it doesn't capture the reality. You could fit 1,300 Earths inside Jupiter. Think about that number. Not 13, not 130, 1,300. If Earth were a marble, Jupiter would be a basketball. But here's where the scale becomes truly disturbing. Jupiter's mass is greater than every other planet in our solar system combined. Every planet, every moon, every asteroid, Jupiter outweighs all of it, twice over. Put differently, if you could somehow place Jupiter on one side of a cosmic scale and put Mars, Venus, Earth, Mercury, Saturn, Uranus, Neptune, and every moon and asteroid on the other side, Jupiter would still be heavier. And that mass creates consequences, gravitational consequences, consequences that have shaped the entire architecture of our solar system in ways most people never realize. But we'll get to that. First, we need to talk about what Jupiter almost became. Here's something that should keep you awake at night. Jupiter almost became a star. Not almost in some vague metaphorical sense. Almost in a very specific, terrifying sense. If Jupiter had been just 80 times more massive during its formation, nuclear fusion would have ignited in its core. Hydrogen atoms would have begun fusing into helium. Heat and light would have radiated outward. We wouldn't have a solar system with one sun and 8 planets. We'd have a binary star system, 2 suns. And Earth? Earth might never have formed at all. The gravitational dynamics of a binary system are chaotic. Stable planetary orbits become rare. The habitable zone shifts. Everything changes. But Jupiter didn't quite make it. It stopped growing just short of the threshold. It became what astronomers call a failed star, a gas giant with no solid surface, crushing internal pressures, and an appetite for destruction that has never stopped. And in some ways, that makes it more dangerous. Because a failed star doesn't just sit there. It influences everything around it in subtle, persistent, relentless ways. Now let's talk about what's happening on Jupiter's surface. Except there is no surface. Jupiter is a gas giant. Layers of hydrogen and helium that get denser and denser as you descend. The atmosphere simply gets thicker and thicker until the pressure becomes so extreme that hydrogen transforms into liquid metal. But before you reach that depth, you'd encounter something far more terrifying: the storms. The Great Red Spot. You've seen pictures of it, a swirling red oval that looks almost peaceful from millions of kilometers away. It's not peaceful. It's a hurricane larger than Earth itself, a storm that has been raging for at least 400 years, possibly much longer. We don't know because humans haven't been around long enough to see it start. Wind speeds at the edges of the Great Red Spot exceed 400 kilometers per hour, and that's considered calm by Jupiter's standards. Deeper in the atmosphere, jet streams tear across the planet at over 600 kilometers per hour. These aren't gentle breezes, they're walls of gas moving faster than the speed of sound on Earth. And they never stop, never weaken, never dissipate. Earth's hurricanes last for days, maybe weeks. Jupiter's storms last for centuries, because there's no land to slow them down, no friction to bleed away their energy, just endless gas churning in patterns that have persisted since before human civilization existed. But the storms aren't the scariest part of Jupiter, not even close.
Earth has a magnetic field. It protects us, deflects charged particles from the sun, makes life possible. Jupiter has a magnetic field too, but it doesn't protect, it destroys. Jupiter's magnetic field is roughly 20,000 times stronger than Earth's. If you could see it with your eyes, it would appear larger than the full moon from Earth's surface, even though Jupiter is hundreds of millions of kilometers away. It extends millions of kilometers into space. It's the largest structure in our solar system, and it's completely invisible. But here's what it does. It traps charged particles from the solar wind and accelerates them to near light speed. These particles form radiation belts so intense that they would kill an unprotected human in minutes. Not hours, minutes. When NASA's Juno spacecraft entered Jupiter's orbit, it had to carry a titanium radiation vault just to protect its electronics. The vault weighs 200 kilograms, and even with that protection, Juno can only make close passes for a few hours at a time before the radiation threatens to fry its systems. The Galileo probe, which plunged into Jupiter's atmosphere in 2003, received a radiation dose equivalent to 25 million dental X-rays before it was crushed and vaporized by the pressure. This isn't a planet you visit. It's a planet that actively tries to kill anything that gets close.
But Jupiter's true violence isn't in its storms or its radiation, it's in its gravity. Jupiter's gravitational influence is so immense that it fundamentally altered the formation of our solar system. During the early days of the solar system, Jupiter didn't stay where it is now. Scientists believe it migrated inward, wandering as close as Mars's current orbit before being pulled back outward by Saturn's gravity. This is called the Grand Tack hypothesis. And if it's true, Jupiter's migration destroyed everything in its path. Planets that were forming in the inner solar system scattered, absorbed, ejected into deep space. The asteroid belt between Mars and Jupiter, that's not debris from a destroyed planet. It's debris from planets that never got the chance to form because Jupiter wouldn't let them. Mars should be much larger than it is, but Jupiter's migration prevented it from accumulating more mass. Mars is a stunted world because Jupiter passed through its neighborhood billions of years ago. And Jupiter's gravitational influence isn't just historical, it's ongoing. In 1994, we watched it happen in real time. Comet Shoemaker-Levy 9 was captured by Jupiter's gravity and torn into 21 fragments. Then, one by one, those fragments slammed into Jupiter's atmosphere at 60 kilometers per second. The impacts left scars larger than Earth. The energy released was equivalent to millions of nuclear bombs. If that comet had hit Earth instead, it would have been an extinction event. Total, absolute, the end of complex life. Some scientists argue that Jupiter protects us from such impacts by acting as a gravitational shield. Others point out that Jupiter's gravity also sends objects toward the inner solar system, increasing the risk. The truth is probably somewhere in between. Jupiter giveth and Jupiter taketh away. But make no mistake, Jupiter doesn't protect out of benevolence. It's not our guardian. It's a cosmic vacuum cleaner that happens to sweep up some debris that might otherwise hit us. And when it does send something our way, there's nothing we can do about it. You might think that at least Jupiter's moons are safe. After all, Europa has a subsurface ocean. Ganymede is the largest moon in the solar system. These are places we hope to find life. But even Jupiter's moons exist in a radiation hellscape. Io, the closest large moon, is the most volcanically active body we know of. Not because of internal heat like Earth's volcanoes, because Jupiter's gravity literally kneads it like dough. The tidal forces are so extreme that Io's surface is constantly erupting, reshaping itself every few years, sulfur and silicate lava fountaining hundreds of kilometers into space. Io isn't a moon, it's a torture chamber. Europa, the moon with the promising subsurface ocean, orbits within Jupiter's radiation belts. The radiation on Europa's surface is lethal. Any spacecraft that lands there will have to drill through kilometers of ice just to have a chance at finding shielded water below. And even then, the electronics will face constant bombardment. Ganymede has its own magnetic field, the only moon in the solar system that does. But even that isn't enough to fully protect it from Jupiter's radiation onslaught. These moons aren't refuges, they're prisoners, trapped in orbit around a monster that never stops punishing them for being too close. Let's pause here and really absorb what we're dealing with. Jupiter is 318 times more massive than Earth. Its magnetic field extends millions of kilometers. Its storms have been raging for centuries. Its gravity has shaped the architecture of our entire solar system. And it's been doing all of this for 4.5 billion years, long before Earth had life, long before our sun will die. Jupiter represents a fundamental truth about the universe that we often forget. Scale matters, mass matters, and when you combine enough mass in one place, the rules change. Jupiter operates on a different level than Earth. The physics are the same, but the outcomes are incomprehensible to minds that evolved on a small, relatively calm planet. We look at Jupiter and see beauty, swirling clouds, majestic bands, a cosmic work of art. But that's because we're looking from a safe distance. Get close and you realize the truth. Jupiter is a failed star that's still trying to be violent, a gravitational monster that reshapes everything around it, a radiation source that would kill you in minutes, a storm system that has never stopped raging. And it will be here long after we're gone, long after Earth is a dead rock, long after the sun has expanded into a red giant and consumed the inner planets. Jupiter will still be there, still churning, still destroying, still waiting.